Hello folks, this is one of the balancing redox reactions problems from the WebAssign. There are a couple of videos on this type of work by Tyler DeWitt, which I've posted on the Canvas a few days ago. The first thing to do is to divide this into two half reactions. Something is getting oxidized here, and something is getting reduced here. Usually it's not the oxygen. Usually it's the other thing. So in this case, I've got chromium and chromium. That means chromium is probably getting oxidized or reduced. I've got sulfur here and sulfur. That means sulfur is probably getting reduced or oxidized. So let me start with the chromium. I just write this as a separate chemical reaction. Leave myself a lot of room here. Okay, so I have written this one and this one. This is a half reaction. I will do the other half a little later on this video. Now, the first step is to balance everything that's not oxygen. Well, the chromium is not oxygen. There's one of them here, and there's one of them here, so that's balanced. The second step is to add waters. And the third step will be to add hydrogens, and the fourth step will be to add electrons. Waters, hydrogens, electrons. Waters, hydrogens, electrons. That spells we, as in wee! So I'm going to use the wee steps. Isn't that fun? So there are 4 oxygens here, so I'm going to add 4 waters, because each water brings 1 oxygen. Now there are 4 oxygens here, 4 oxygens here. There, that's good. Now this is done in an acidic environment. That's why we add the H after we're done with the water. There are 8 H's here, so I'm going to put 8 H's here. Okay. Now the total charge on this side is 8 positive and 2 negative. So 8 minus 2, that's positive 6. That's a total charge of positive 6. On this side, there's a total charge of positive 3. The charges need to be balanced. I'm going to add electrons. Will I add electrons to this side or this side to make the charges into 3? I'll add them to this side because charges are negative. So if I put negative 3 on this, I'll get positive 3. So I'm going to add 3 electrons right there. Okay, just clean up a little bit here. Now I'm going to do exactly the same thing to the other half, except I'm going to do it in a different color. The other half is the sulfurs. It's not very vividly a different color, is it? How about this? The other half is the sulfurs. That's better. So the other half says S2O3 2 minus produces SO4 2 minus. I've got to balance everything else that's not oxygen or hydrogen. There are 2 S's here. I'll only make 2 S's here. Now, the oxygens, because I'm going to add water. Whee! All right, so 3 oxygens and 8 oxygens. Well, the difference between 3 and 2 times 4, 8 is 5, so I'll add 5 waters here. That's the water. Now the hydrogen. There are 10 hydrogens. There are no hydrogens, so I'm going to add 10 hydrogens. WHE. Now the electrons. Let's see, there's a negative 2 charge right here, and there are 2 negative 2 charges, so that's negative 4, and 10 positive charges. So positive 10 minus 4, that's positive 6. So I've got positive 6 on this side. I've only got negative 2 on this side and positive 6 on this side. Well, I can only add electrons. I can't take away electrons because there are no free electrons here. All the electrons are stuck to atoms and molecules. So I'm going to add a whole bunch of electrons to this side until I can cancel out this 6 and get a negative 2. Okay, that'll be 8 electrons, please. So I'm going to need 8 electrons. That's a tall order. 8 electrons, that's negative 8, a total charge of negative 8 here, plus the existing total charge of positive 6. That's going to get me a resultant charge of negative 2. And that's what we have here. 2 minus, indicating a negative 2 charge. So now the electrons are balanced. That's great. Now, there still is a problem, though, because I now need to combine these two equations, the purple one and the green one. But in order to do that, the electron number needs to be the same. So I've got 3 electrons on the reactant side. I've got 8 electrons on the product side of the other equation. The idea here, folks, is that the electron numbers need to cancel out. So this number needs to be the same as this number so that the reactant side can cancel out with the product side, because I'm going to be combining these two equations. There are only half reactions of a total reaction. How can I get this number to be the same as this number? What can I multiply this whole purple equation by? Or what can I multiply this whole green equation by so that this number will end up being the same as this number? Well, I could try 24. I mean, 3 times 8 is 24, so if I multiply all of these guys by 8, 8 times 8 is 64. 8 times 4 is 32. 8 times 3 is 24. Then I'll get 24 electrons. If I multiply all these guys by 3, 3 times 2 is 6. 3 times 10 is 30. 3 times 5 is 15. 3 times 8 is 24. Okay, now I have 24 electrons on this side, 24 electrons on that side. I'm going to add these up. I've got to keep the reactants separate from the products. Okay, I've got 8 chromate ions, and that's with 64 hydrogen ions. Actually, it's not, well, I'll just write them all down. And that's with 3, thiosulfate. That's with 3 thiosulfate ions. That's with 15 water molecules. I know these numbers seem high, but I'm going to cancel out an awful lot of stuff over here, okay? Those are the reactants. Now for the products. So these are all the reactants. Let me circle them so that you get the idea. These are all the reactants. All this added together will get me 8 chromium 3 ions, 32 water molecules. Chromium 3 is a dangerous substance. And I've got 6 sulfate ions. And I've got 30 hydrogen ions. I've got 24 electrons. Okay, now I'm going to go through and I'm going to cancel everything out that appears on both sides, the reactant side and the product side. For example, 24 electrons. Oh, I didn't add the 24. Oh, I forgot the 24 electrons right here. Sorry about that. Thank you if you noticed that. 24 electrons. So that needs to be in here too. 24 electrons plus 24 electrons. Okay, so I just copied everything that's on the reactant side down here. I copied everything that's on the product side down here. Now the 24 electrons appear on the product side and on the reactant side, so they get canceled out. 15 waters. Water appears on the product side and the reactant side. So 15 waters cancel out here. So I'm going to take 15 out of here also. So that's going to get me a result of 17. Because 32 minus 15 is 17. Now what else? What else can I cancel here? Some hydrogen ions, H+. There are 64 of them here. There are 30 of them here. So these guys are gone with 30 of these guys. That's going to leave me with 34 left over. So the resultant, excuse me, so the resultant balanced redox equation is 8CrO4 2 minus. I should do this in a different color, shouldn't I? So it's less confusing. I mean, so it's cleaner. I think I've used all the good ones. I guess I have to use a weird one, orange. So 8CrO4 2 minus, copying them down over here, plus 34 hydrogen ions, plus 3 thiosulfate ions, S2O3, 2 minus, and that's it. That makes 8 chromium 3 plus ions plus 17 waters plus 6 sulfate ions. And when you enter this in WebAssign, these all need to be AQ, of course. AQ, AQ, AQ. I won't bother to write them here because it just looks too messy when I write it on the board here. But there you go, folks. That is the balanced redox reaction. A summary of the steps again, folks. First, you divide your equation into two equations, two half reactions. I've got the chromium going on over here in purple, and I've got the sulfurs going on over here in green. I've just copied these chemicals down straight from the whole equation, and I've made two halves. Excuse me. Next, you balance all the elements that are not oxygen or hydrogen. So the chromiums were already balanced, and there was one of each. And the sulfurs, I needed two of these and one of these. Right? Next, you put in water molecules to balance only the oxygen. We're only interested in the oxygen with this step. So I've added a whole bunch of water molecules here to get oxygens, because there are oxygens on this side, but there weren't any on this side. And I did the opposite over here. There were too many oxygens on this side compared to this side, so I added a whole bunch of waters on that side. Next, you add hydrogens to balance the hydrogen. The hydrogens are added as H plus ions because H plus ions make acid, and this is supposedly done in an acidic solution that has to be given to you in the problem. It can't be something that you make up or figure out. And finally, you add electrons to balance the total charge of the reactants with the total charge of the products in each half reaction. And then after that, you must multiply your entire equations by a certain number. You could use a certain number for the purple equation and a different number for the green equation. And the object of that game is to get the same number of electrons as you have the reactants on one half reaction as in the products of the other half reaction. Then you add up those reactions. You write down all of the reactants for both half reactions and all of the products for both half reactions. And then you cancel out the electrons because you designed this with math to get the same number of electrons on the reactant side as the product side. And you go ahead and cancel out everything else that can be canceled out. Most of the time, like in my case here, you're going to find that things don't cancel out perfectly. And you like in the case of this hydrogen here, there are 30 over here, 64 over here. So these 30 cancel out with 30 from here, but then you have 34 left. And then you just write down, you rewrite everything somewhere else on your paper, on your note page, to get the total balanced redox reaction. That's all, folks. Dun, 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 dun.